C naught equal to xn such that xn comings from real set and xn tends to 0. It means all those real sequences having limit 0 and set m defined as this means first 10 terms 0 is first 10 term sum is 0, then dimension of C naught by m is equal to, it means dimension of quotient space. First, the beauty of this question is as C naught. Here, C naught is infinite dimensional vector space. As you can see, there are infinitely many sequences which tends to 0. So, infinite linearly independent sequence in C naught. So, dimension of C naught equal to n. Dimension of C naught is infinite. Now this question is about the dimension of C naught quotient space C naught by m and asked in numerical answer type means its answer will be a numeric value means 2, 3, 4 and something, but dimension of C naught is infinite. It means dimension of this maybe, it is our concern, dimension of C naught is finite or infinite, but as this question asked in numerical answer type, so it is clearly understood dimension of this is finite. Also dimension of m, as dimension of m is also infinite, but whenever we relate this dimension with C naught, then its dimension will be 1 less, means dimension of C naught minus 1. Why? Because here you can see one linearly independent restriction contained in M. So dimension of M will be 1 less than dimension of C naught. If you consider C naught as n dimensional and n tends to infinity. So dimension of C naught is infinity, then dimension of m is less 1. Have any sense? Means infinity minus 1 is have any sense in real system or not? This is your concern, you can think about it, but it is clearly understood dimension of m will be 1 less. Now you can justify this point as by Archimedean property. If you have any real number, then you can find a greater natural number. If you have any real number, positive real number, or if negative, then we have many natural number, but if you have any larger and larger real number, then you can find a natural number greater than that real number. So this is a point same as natural numbers are infinite and we don't know which natural number is largest, but we always can find a natural number either adding 1 or around that point. Similarly we can justify this point, otherwise you can stuck in this as dimension of C naught is infinite, how dimension of m will be minus 1. It has no sense, because dimension of m is also infinite, but you can justify your argument or approaches why as Archimedean property. Now come to the point, dimension of C naught over m. Dimension of C naught over m, as this is quotient space, so dimension of C naught over m will be dimension of C naught minus dimension of m. Now dimension of C naught is same as, and dimension of m is dimension of C naught minus 1, it means 1. So dimension of C naught over M means quotient space C naught over M is equal to 1. So answer of this problem is 1, and the beauty of this question is as C naught is given and M naught defined. Defining of these spaces is beautiful